In this video, we're going to do another example with variance and standard deviation. With this particular example, we have dog heights. We have 600 millimeters, 470 millimeters, 170 millimeters, 430 millimeters, and 300 millimeters. And we want to find the variance and the standard deviation of this data. So again, just like I did with our last example, I'm going to use a small chart to help organize this information. 3 columns is usually very helpful. So I'm going to list the data first. 600, 400. We don't have to worry about ordering the data. It doesn't have to be small to largest or largest to small. So in the first column, I'm putting my data values. The next thing I would need to do is to find the mean for my data. So I'd add all the data up and divide by the number of data, which is 5, and I find the mean to be 394. And so then in my next column, I'm going to take the data value and subtract the mean. So 600 minus 394 is going to give me 206. 470 minus 394 is going to give me 76. 170 minus 394 is going to give me negative 224. 430 minus 394 is going to give me 36. And 300 minus 394 is going to give me negative 94. So that's my second column. My value, my data value minus the mean to get that second column. Again, remember we talked about if we added this column up, we should get 0 there. That's what happens every time with every set of data. In my third column is where I'm going to do the squaring. So I'm taking my answer from the second column and squaring it. So 206 squared, I get 42,436. 76 squared is 5,776. Negative 224 squared is 50,176. 36 squared is 1,296. And negative 94 squared is 8,836. And I want to add that column up, and I get 108,520. And so to find my variance, I'm going to take that total, 108,520, and divide it by the number of data items, which is 5. And this time, let's make this population instead of sample. So I'm going to go through and just kind of switch these variables a little bit. This should be mu. And let's use this little squiggly guy. So instead of doing n minus 1, let's keep all the data and say that's 5. We're using the entire population. And so the variance is 21,704. Next, we want to find the standard deviation for the population. And so that just means I'm going to take the square root of 21,704. And so that answer turns out to be 147.32. Now let's just look at the reasonableness of that answer. It does kind of fall in line a little bit with what's going on there. So that's telling us that the data is spread out by maybe 150 values from the highest to the lowest. So the data does have a bit of range between the variation of the values. We've got a really large dog compared to a little small dog. So it does vary quite a bit. And that's the next thing that we need to talk about is what does knowing the variance and knowing the standard deviation, what kind of information does that give us about our data? So let's look at this situation. We have company A and we have company B. And we're wanting to compare these two companies that put sugar in little packets. And the mean for company A is 1.013 teaspoons of sugar in their packet. The mean for company B is 1.007 teaspoons of sugar in their packet. When we look at the standard of deviation, we get 0.0021, and for company B, we have 0.0018. So we want to be able to answer a couple of questions. Which company provides more sugar in their packets? Well, what measurement would we look at to figure that out? And I think we would look at the mean. The mean is that how much is going into the packets. And so we see that company A is providing more sugar. It had the bigger mean of the two companies. The next question that we want to look at is which company is more consistent with filling the package. And that's where we look at the standard deviation. How much do the packets vary? Do they vary a lot or a little? And as we compare the two companies, the smaller variation is the one that is being more exact with filling their packets. And so that means B is the company that has the smaller difference in what they're putting in their packets. So we said company A had the most sugar in the packets, but company B is more consistent with filling their packets. So this is a way that we can use measurements like mean and standard deviation to interpret information, and so we can use it to help provide good decisions about the information.